It is the most anticipated stellar death of our time. When the giant star Betelgeuse transforms into an explosive supernova, it will shine in the sky as brightly as the full moon and can even be seen in daylight. Unfortunately, however, we do not know when exactly this brutal demise will take place. After the stellar colossus was almost pronounced dead following some mysterious fluctuations in brightness, it ultimately recovered, well, until now. Betelgeuse is again attracting attention with mysterious displays of light, and a new study concludes that the shoulder star of Orion could explode much earlier than expected. In 2019 and 2020, the excitement surrounding Betelgeuse was boundless. The giant star indeed made headlines with a drastic loss of brightness, which many experts interpreted as a harbinger of the approaching supernova. There is no question that the explosion of this gigantic celestial body will be an overwhelming spectacle. After all, the red supergiant, which is only 650 light-years away, is 800 times the diameter of the Sun and already shines 10,000 times brighter than our source of warmth and life in visible light. As a result, Betelgeuse is one of the brightest stars in the night sky, which is why the development that began in October 2019 seemed all the more confusing. The star's luminosity is normally estimated to be between 0.3 and 0.4 magnitudes. To put this into context, the unit magnitude, or mag for short, indicates the apparent brightness of a star without taking into account the distance of the celestial body. The smaller the mag value of the star, the brighter it appears to us in the sky. When Betelgeuse dimmed, researchers recorded a drop in brightness down to 1.1289 mag, while the temperature of the stellar giant dropped by a good 100 degrees Celsius in the same breath. In detail, the drop in luminosity was so significant that it could even be seen with the naked eye, causing Betelgeuse to slip to 21st place on the nightly star chart. But how is it that astronomers associate such a spectacle with an imminent supernova? On one hand, there is the fact that the so-called Orion shoulder star has reached the last stage in its development as a red supergiant, which will inevitably end in a powerful explosion. On the other hand, there is the fact that this can be announced by strong expansion combined with a decrease in brightness. But this is precisely where it gets tricky, because the astronomical truth also includes the fact that, so far, there have been no precise observations of supernovae before their explosion. In light of this, we also don't know whether dimming occurs several years before the supernova or just a few hours before. What we do know, however, is that Betelgeuse should not disappear from the cosmic scene at that time because we would inevitably have noticed it. According to experts, Betelgeuse will shine as brightly as the full moon for weeks. The dying colossus would be so bright that it would be almost impossible to see the other stars in its vicinity. Since it would be the brightest supernova in the history of observation and the one closest to Earth, it could even be seen in daylight. The biggest drop in brightness in the last 2 years poses new puzzles. If the dimming 5 years ago was not linked to a final explosion, what was it caused by? Dust. Subsequent observations with the Hubble Space Telescope revealed that a huge plasma eruption created a massive dust cloud that darkened the star by almost 2/3. Although Betelgeuse, as a stellar oldie, regularly ejects large amounts of stellar material, this event was something else. A combination of strong convection and expansion probably caused the plasma eruption to be 2 to 3 times stronger than usual and resulted in a loss of mass 30 million times greater than that of the Sun. Soon after, Betelgeuse returned to its original luminosity, yet it still had 1 or 2 brightness puzzles in store for us. In the period that followed, the development in 2023 was reversed, and the star shone significantly brighter than average. However, true to the motto, where there is light, there is also shadow, the celestial body lost a drastic amount of luminosity again a few months ago. Although the brightness did not change quite as drastically as in 2019 or 2020, researchers still recorded the lowest luminosity in the last 2 years. In view of this, the question arises again as to whether this development could be related to an imminent supernova. Yet the answer remains: we don't know. No expert can currently say with absolute certainty whether the giant star will explode tomorrow or in a million years. The bottom line is that it's theoretically even possible that Betelgeuse has long since made its blazing exit and that the light of its last stellar act has simply not yet reached us. A study from 2023 actually comes to the conclusion that Betelgeuse may explode much earlier than previously thought. In the run-up to this, a research team from Japan's Tohoku University in Sendai examined the pulsation of the star and uncovered a series of astonishing circumstances indicating that Betelgeuse is much older than previously thought. As the outer layers of Orion's shoulder star pulse, this results in relatively regular brightness variations, the most prominent of which last 2,200 and 420 days, respectively. Until now, astronomers had interpreted the shorter interval as the star's heartbeat, suggesting that we are dealing with a younger celestial body. But what if the 2,200-day period actually represents the true stellar pulse? That would mean, first of all, that Betelgeuse is even bigger than generally assumed. Expressed in numbers, the 800-fold solar diameter would thus turn into a diameter 1,200 times larger than that of our mother star. This would also mean that Betelgeuse is further advanced in its life cycle and that its supernova is inevitable. Will Betelgeuse soon explode? The fact that stars transform the night sky into an endless sea of radiant points is due to the spectacular processes taking place in their interiors. Stars shine because they fuse hydrogen into helium at their core, and as soon as the hydrogen supply in the core is exhausted, helium is used to create carbon. This carbon is then burned, with increasing age, to form other heavier elements. Japanese study authors used computer simulations to demonstrate how these blazing celestial bodies evolve from their birth to the final stages of their lives, and when they begin to pulsate. They uncovered an astonishing fact. All the recorded pulses from Betelgeuse can be assigned to a much later stage than previously assumed, the carbon-burning stage. The study suggests that just a few dozen years after the carbon in the core is exhausted, a core collapse is expected, leading to a supernova explosion. Unfortunately, it was not possible to pinpoint the expected date of the star's death more precisely. The researchers estimate that the time until carbon depletion could be less than a few hundred years, which is significantly earlier than other predictions suggesting the supernova will not occur for another 100,000 years. However, the Japanese study results are not free from criticism. For instance, astrophysicist Morgan McLeod has pointed out that the findings do not align with other studies of the star. If the 2,200-day cycle is considered the main heartbeat, then Betelgeuse would become too large, raising questions about the study's validity. Despite this, it is also possible that Betelgeuse is not only surrounded by questions, but also by a hidden companion. New analyses suggest that Betelgeuse may have a partner star whose existence has eluded humanity for thousands of years. The longer 2,200-day fluctuation in the star's light curve became the focus of astronomical interest. A re-evaluation by a team from New York's Flatiron Institute revealed anomalies, such as the 2,200-day cycle following a different rhythm than the shorter 400-day pulsations. The scientists could not attribute these anomalies to rotation sequences, magnetic field effects, or convection currents, leading to the hypothesis of a smaller companion star. The long periodic brightness variations might reflect the orbits of this companion star. When it disappears behind Betelgeuse from our perspective, the brightness reaches its minimum. Conversely, when the companion is next to Betelgeuse, their combined luminosities create a maximum brightness. The companion star might also act as a natural dust shifter, influencing the dust cloud distribution and contributing to Betelgeuse's brightness changes. If this hypothesis is accurate, how has the companion been overlooked for so long? Its low mass, calculated at just 1.7 solar masses, makes it 12 times lighter than Betelgeuse. Additionally, it orbits Betelgeuse at a small distance, corresponding to just 2.43 Betelgeuse radii, causing it to be outshone. The star's pulsations and brightness fluctuations further complicate identifying the companion. Fortunately, complicated does not mean impossible. Researchers now hope to use large telescopes to gather more evidence of the companion star's existence and possibly determine its type. With these discoveries, the mysteries surrounding Betelgeuse continue to captivate astronomers and enthusiasts alike. If you enjoyed this detailed exploration of Betelgeuse, we'd appreciate it if you pressed the thumbs up button and subscribed to never miss another exciting video. See you soon.